So in this video we look at a different sort of calculation to do with a normal distribution. We work out a score, it's a score calculation, given a probability or a proportion for a range of scores. So we'll look at two examples. Here's the first one. The height of all Year 12 female students are assumed to be normally distributed with a mean of 175 centimetres and a standard deviation of 6 centimetres. We need to find out how tall Alina is if she's taller than 95% of all Year 12 female students. Now, second example seems very impractical. It doesn't seem to have much use, but it is actually a very important concept for understanding a lot of probability questions to do with the normal distribution. We need to find k if the probability that z is less than k is 0.1. So let's look at each of these examples in turn. The first one, let's draw a diagram for it. Here's the diagram. The mean, the population, 175, indicated by the dashed line, mu. Sigma is 6, that's the standard deviation. Now, Alina's taller than 95%, in other words, she's in the top 5% of all Year 12 female students. So I've shaded there 5% under the normal curve. 5% is equivalent to 0.05, and indicated with an arrow that Alina is somewhere in that. She's somewhere in the shaded region. So what we need to do, in essence, is to find the value of k, that cutoff line, for the probability of 0.05. So we're going to use our graphics calculator for that. So we need to be in statistics mode. We're dealing with a distribution. We're dealing with a normal distribution. And this time, because we're working back from a probability or proportion to a score, a range of scores, we're using the opposite inverse norm is what we need to choose. Now, we're dealing with variables. We're not dealing with a list which is in our calculator. So if this was set as list, we'd have to click on this button to change it to variable. It's already done. Now, by some previous calculation, the tail, that's the area that's been shaded, is to the right of the diagram. So that's been selected correctly. And now we need to put in the area. The area shaded is 0.05. The standard deviation we're told is 6. And the mean of the population is 175. So when we hit EXE, we find out that that probability holds for a score of 184.86 and beyond. So k is 184.9 rounded off to 1 decimal place. In other words, we can say that Helena is at least 184.9 centimetres tall. And of course, it's Alina, not Helena. Now this problem, which seems a bit meaningless. We're dealing with a standard normal distribution, so Z scores. So we know the mean is 0 and the standard deviation is 1. So again, drawing a picture. Now we've shaded 10%, 0.1 is 10% of the area, and it's Z less than K. We're trying to find this number here, K. So we're shading to the left here, and we're going to use our calculator again. So now going back. Now we know we're in the inverse norm section here, so we can just use that. Yes, it's a variable we're dealing with again. This time the tail is to the left. So we click on this button to make it to the left. The area now shaded is 0.1. Because it's a standard normal distribution, the standard deviation is 1 and the mean is 0. Hit EXE and we see that this score here, the probability of Z being less than that, is 1.28 to 3 significant figures. In fact, it's because it's to the left of 0 is negative 1.28, isn't it? So there we have it.